It says, for what value of t does y equal the square root of 3t minus 2 over t have a horizontal tangent? So the first thing we have to do is find our derivative of y. So dy dt is equal to ho d high minus high d ho all over ho ho. So your first step should be to have dy dt equals, and then you have all of this. Now, the problem with what we currently have is that we have a square root that's to the negative. So it's going to drop that square root down. So this simplifies to 3t over 2 square roots of 3t minus 2 minus the square root of 3t minus 2 all over t squared. So what we have to do is get a common denominator. So I'm going to multiply by 2 square roots of 3t minus 2. And then what I'm going to do from there is group my denominator together. This denominator, because it's a fraction within a fraction, is always going to bump up as well. So I'm left with 3t minus 2 times 3t minus 2. Square root's gone because square root times square root of the same thing cancels. All over 2t squared square root 3t minus 2. And then that will simplify. This becomes 6t negative positive 4. So 3t minus 6t is negative 3t plus 4. All over 2t squared square root 3t minus 2. So that's your derivative. Once you have your derivative, then what we're going to do is only set the numerator equal to 0. So essentially a fraction is going to give me two different types of tangents. The numerator is going to give me the horizontal tangent, or the tangent essentially where the slope of the derivative is equal to 0. And that's only coming from the numerator. So horizontal tangent is going to come from the numerator set equal to 0. So in this case, my horizontal tangent is negative 4 over negative 3, which becomes a positive 4/3. So what that means is that at 4/3, the slope of the derivative is equal to 0. And if you go back to our important chart with the f prime, etc., if the derivative is equal to 0, then our original has an extrema. So if the derivative is equal to 0, then the original has an extrema. So basically what this is telling me is that at t equals 4/3, we have an extrema on y. Okay, so then that was number 17 from the trig circuit packet. Also, let's look at 13 from the additional packet. And honestly, 13 is probably one of those tricky ones on that packet. Okay. So number 13, we have f of x equals the tangent of 5x cubed plus x. So again, remember any trig function to a power is really like that trig function inside raised to a power. So there's my original. And then my derivative is equal to 5, the tangent of x cubed plus x. But then we take one of those powers away, so it's going to be to the 4th. And then, now you've done the outside. Now we have to take the derivative of the inside. So there's actually 2 chain rules happening inside, so this is like a 3-part problem again. It's kind of like your f of x is x cubed. Your g of x is tan x, and your h of x is x cubed plus x. So again, this is kind of like a triple problem. So then you have to multiply by the derivative of tangent. So the derivative of tangent is secant squared. And then we still have one more inside. We have to multiply this by the derivative of h, which is 3x squared plus 1. So then this and this are kind of like our constants. So we just rearrange it. So it's 5, 3x squared plus 1, tan 4x cubed plus x, secant squared x cubed plus x. All right. Any other issues, questions, concerns from either of those 2 packets so far? And again, you guys are welcome to unmute so you can ask me, talk to me, etc. It's feeling real lonely. Okay, so then let's jump down. I also, on this handout, did your 14, 15, and 16. And up at the top, we have 17. So again, start by taking the derivative of tan. So derivative of tan is secant squared x squared. And then you have to multiply by the derivative of the x squared, which is 2x. So you have 2x secant squared x squared. Okay, 18. Hopefully you realize that I told you guys to ignore all the inverses. If you did not, we're going to cross out that arc. Again, arc means inverse. So we're going to treat this like a product rule. So it's first times derivative of the second, which is the exact function from here, plus the second times derivative of the first. And then what you'll notice is we end up with 2x cubed secant squared x squared plus 2x tan x squared. Okay? And then 19 f prime of x, derivative of secant is secant tan. Now this one, you got to be careful. You need to make sure you write that secant and tan with the square root. So that square root's kind of like my u value. So it's kind of like secant u. So derivative of secant u is secant u tan u times u prime. So then now we multiply by the derivative of that inside. So it'd be 1/2 x squared minus 1 to the negative 1/2 times derivative of x squared, which is 2x. So we get 2x secant square root x squared minus 1 tan square root x squared minus 1 all over 2 square root x squared minus 1, and you could cancel the 2's. And then number 20, you have your first, which is x squared, times derivative of the second. Make sure when you do derivative of the second, you take the derivative of the inside, which is 5, plus the second times derivative of the first. So again, first times derivative of the second plus second times derivative of the first. And we can take out a x secant 5x, leaving 5x tan 5x plus 2. Okay, so if that's all the questions we had on these two packets, then we will pick up and start with our chain rule review for the day. Okay. So chain rule practice, it is asking me, and again, this is kind of the notation I'm hinting at as well, making sure we totally understand everything on that page. So my function is y equals tan cosine x. dy dx is telling me to take the derivative with respect to x. So we're deriving y with respect to x. And x equal pi halves means to evaluate the derivative at pi halves for x when we are done. So we'll start with dy dx. So outside function is tan. So derivative of tan is secant squared cosine x times the derivative of the inside function. Derivative of cosine is negative sine x. So we have outside times derivative of the inside. And then after we take that derivative, what we're going to do now is plug in to that problem. So basically what that means is we are going to take dy dx and evaluate for x at pi halves. So you have secant squared cosine pi halves times negative sine pi halves. So again, cosine of 0 is 1. Therefore, we get 1 over 1, which is 1. 1 squared is 1. So you get 1 times negative 1, which is negative 1. Number 2.